Hello, I'm Mr. Brundage. We're going to do a ASTM 1330 descaling sandblasting of this piece of pipe. This is kind of a special piece of pipe because it's for oil, movement oil, and different hot gases and things like that. It's 1/4-inch steel. We're going to descale it. We're going to take the paint off it, and then we're going to turn it over on one side, and we're going to put the sand here, and we're going to blast to that surface for 1 full minute on this scale. Now, this is according to ASTM 1330 law, but we're also going to do the ASTM A262 law. So on this, according to its bylaws. So we'll be doing several tests on this. A sublimation of gases. We're going to do a heat transfer and thermal transfer, and we're going to also do combustion. And we're going to do scarification, intimation, different things that we're going to be doing to this piece of pipe. So what we're going to do is we're going to take our sandblaster here. I'm going to put my glasses on here. And what we're going to do is we're going to see if this sandblaster is set enough to pull this paint off of this piece of pipe, because in the desert or wherever, or whatever steel, your airplane, your car, your bicycle, your motorcycle, whatever, if you pull the paint off of it, that isn't good in a sandstorm, so we want to keep the paint off of it. So this paint does that. It's biodegradable, non-toxic, recyclable, edible, and environmentally safe paint. All right. Okay, that's done. Now you should put this up where it can be seen a little better. Alright, now we're going to do this side for 1 full minute. Right here on the composite, the paint, the two flame out. So we'll hold it for 1 minute. We'll set our scale here and set our time. You can man that scale. And you just tell me when, and we'll plug in and we'll do a descaling. Tell me when you're ready. Back off. No, I still got plenty of sand.
Okay, there you go.
Alright, now
We zoom in.
zoom in, check your surface. As you can see, there's no descaling, although it did take off the metal. Took the metal off in about 6 seconds. So for metal products, or your fence or your house or your car or your motorcycle, your bike or your airplane, whatever it takes, then whatever this coating goes on, this coating is going to protect it. The paint needs to be a paint that is easy applicable in a sense, but easy to apply, but does a multitudes of different jobs. But also a paint that needs to go back to the waste management and complement the soil, not destroy it, so that it decomposes in the dumps. This paint does. Now it's not the paint that does it, it's the compound 2 flame out that's in it. Now we make a compound 2 flame out, armor green, and we make insole armor. It's the 2F products, many other products. Okay? Thank you. This is prototypically the ASTM-E 285 open torch test for heat transfer and vertical flame spread and sublimation, emissivity, transfer of heat, heat flow, flux, and also for toxic gases that are given off. We're trying to break down this paint just to see what it'll take. Now, this is a 1-minute burn with MAP gas. This is MAP gas. It's MAPP. This is not MAP Pro. This is a lab grade MAP gas at 5,301 degrees. So we're going to give it our test. Okay, you ready? Our heat temperature. That's incinerate. Put it in Fahrenheit.
102.9 degrees.
Okay. Are we ready? Start your time. You ready? Yep. This is a way of finding out whether or not under ASTM rules that this material will stand up under this kind of heat. Now, the setback is always 8 inches. The burn time is normally 30 seconds. So we're going to go a full minute at 5,301 degrees. That flame at its tip will reach out, or actually extend out 18 inches. So that pipe is very hot. Now, would you like to come around here and do a heat test on it right now, and they'll tell you what the heat transfer is in the pipe. We're looking for gasification, sublimation, any off-gassing. We're looking for heat transfer. We're looking for bubbling, warping, cracking, crazing, descaling, anything. And at this point, we're not. What is our temperature now?
139.
We're 1,300 degrees. Is that what you're reading? No, it's 140 degrees.
Here, turn it so I can get it in the video.
Get in the video.
50.
Okay, what's our time?
Over 1 minute, 9 seconds. How long you want to do it for?
Okay, now, we're going to go a full 2-minute burn, but off the clock. I just want to see what it's going to do in 2 minutes. Try a heat test. See where you're at in heat. Right.
1542.
What degree? 173.
173?
Okay, that's good. Now, we far exceeded the ASTM E285 open torch test with MAP gas at 5,301 degrees. An Aarmourtherm test for 2 flame out. There's no cracking. There's no crazing. There's no heat transfer. There is no indication of any kind of sublimation of gases or anything. This is also, again, an Aarmourtherm product, 2 flame out, which is we make many products, but this specific product right here could coat just about anything. Fences, houses, concrete, steel, whatever you like to coat with it. But this material is biodegradable, non-toxic, recyclable, environmentally safe. You can take it to waste management and recycle it. It is a 2F product that is in the paint. It is not the paint, but it'll go in different paints. So we could put this in on cars or houses or trains or buses or airplanes, whatever you like to put it on. It's up to you. All right, thank you.
Okay, we're doing our heat test on the material.
The 2 flame out, Aarmourtherm 2 flame out.
What was the temperature?
We're doing the E285 open torch test, the vertical test for heat and heat transfer. It is 8 inches away. Can you get that in the camera?
Let me zoom that in real quick.
All right. We are ready. See what our temperature is? A slight sublimation of gases. What is our temperature now? We have a small spot of ablation. We have no blistering, no running, no fluxing, no fusing, no combustion. We're bringing it down to its ambient temperature. What is the temperature right now?
250 degrees.
This is done with MAP gas, not MAP Pro. This is 5,301 degrees. Benzomatic MAP gas, methylacetylene stabilized in propadiene, not MAP Pro. This is 5,300 degrees. Yes, I'm Mr. Brundage, Aarmourtherm Foundation. We're here to do a utility pole test. We've decided to do a utility pole test under the ASTM 1330 law. So we're going to do a vertical flame spread and heat transfer test for our product, Aarmourtherm 2 Flame Out. So we'd like to do this, and I'll go along as I go along, and I'll explain the reasons for the test. The utility poles seem to be having trouble with termites and different things, and so we've got a coating here that works much better. It's highly unscarifiable, and it is bug proof. It's biodegradable, non-toxic, recyclable, and environmentally safe. Aarmourtherm Foundation only makes biosafe products, and we're going to show a descaling test, and we're going to show a E285 open torch flame spread test and heat transfer test through this coating. This coating is a very phenomenal coating, not only for metal but for poles, to coat them, you know, so we can avoid toxins and different things. For instance, creosotes and PCBs, we can eliminate that by putting this barrier on them. Thank you.
Seconds, 36 seconds. No change.
Get a close-up on it?
Yep, so doing that right now.
We're in this area right here. Absolutely no change, no scarification. There is no descaling. There's no difference. So in normal winds, this Aarmourtherm product, this 2 Flame Out, is a highly unscarifiable substance. Yes, this is a prototypical test where we cut into the specimen, which is a jack pine, a Doug fir, or several species of plants that the utility companies use. So we took a specimen out of it and coated it with our coating, And we also took a specimen out, coated it with not only our coating, but their coating. So now, this particular pole here, this utility pole, will be tested. We'll test it with a sandblasting or descaling process that is described in the ASTM 1330 code under those subtitles. But we'll also test a lab test out of specimens, which is the proper procedure when you test a utility wood pole or a specimen in a vertical test for the E285 open flame spread test. We're going to test them both here. We're going to do quite a bunch of different tests according to the code. We'll do the scarification and sublimation, the gas test and off-gassing, for VOCs, and we'll do the Aarmourtherm test in Aarmourtherm 2F compound. All right, thank you. We'll move on.
You're recording.
ASTM E235 vertical open torch test for combustion, sublimation of gases, and heat transfer. This utility pole, what we're trying to do is coat it here and make sure that it doesn't flame up, ember, burst into flames, sublimate gases, chip, craze, crack, blister, or bubble. Make sure that the product will hold up under methylated acetylene stabilized at propadiene at 5300 degrees. This is not MAPRO. This is MAP gas. So, lab grade. So, they'll start the test. The test is for a 1 minute burn. The STM requires only 30 seconds. We're going to get 1 minute burn on this utility pole and see what our heat transfer comes up. See if any combustion or anything happens. Are we ready?
You ready? Got a light? Oh, hold on.
Yeah, there you go.
Where's your minute at?
15 seconds left.
How many?
10 seconds left.
Ready?
5 seconds.
1 minute.
Okay, now we've got a little percolation here, very slight bubbling with a turbo torch at 5,000 degrees, full minute burn, very limited amount of sublimation of gases. The gases are very highly unnoticeable. So we'll get our M40 and we'll test it.
You're a quail.
Chicago.
Chiquita.
Banana.
This is an M40 gas meter, and it measures gases or off-gassing. The percolation or the bubbling is caused from the creosote that's behind the 2F. The gasification of kerosene mixed with tar is the reason for the bubbly surface. However, it maintained it even at this particular temperature. Probably at the tip of that is more like 4,000 degrees. And we have no off-gassing. Our meter shows nothing, and our meter's on because the zeros are all coming up. So it's CO, hydrogen, sulfide, O2, different gases. So now, we're going to move the stand to a higher elevation, and we're going to see how long it takes before it will combust. And then we're going to measure the off-gassing of PCBs as well as aromatic hydrocarbons that are released from the kerosene and tar mixture in the form of creosote. Thank you. This is the ASTM E235 open vertical heat test for combustion, heat transfer, sublimation of gases, intimation, ablation, carbonization. So, you ready? Go. Gasification. I'm seeing off-gassing of some substance coming out of the wood, percolation. More off-gassing, a lot of off-gassing. These are the hydrocarbons, the PCBs, and the kerosene, the creosote that's in the pipe that cause the sublimation of poisonous gases during a fire of a utility pole. Now you can see the creosote and the knots starting to flow out of the hole.
We're coming up on 1 minute. Started gassing off at 30 seconds. Okay, 1 minute.
There's a lot of carbonization, percolation, flux. The heat transfer is pretty high in it. So there's a reason for having a fire retardant on the material. Now, this would be a proper example to show you why. There you go. It's a very simple thing to set a pole on fire. Basically, it's gasoline on a stick. That would be, all of this would be an illegal test because specimens are supposed to be used on a E235 open torch test. This is only a practical application for people who are viewing the movie, but it is done by ASTM rules. So, looks like utility pole companies need to revise the way they do their coatings under the GR60 law because it could cause a lot of damage. However, this highly unscarifiable material, it won't sandblast off. It won't burn off at high temperature. It won't combust. It won't expand or contract or boil or burn or blister even over a straight coating. Now there's no armor green on the back of that coating. So I didn't put armor green and then put the coating. I just put the coating right over the creosote and the PCBs or the insecticides that are in it. They're all highly flammable aromatic hydrocarbons. Now in the specimens we'll do one coated with armor green and one coated just with two flame out additive in the paint. So, and we'll see what they do, but we're going to do a proper test according to the ASTM on the ASTM stand in the lab. So we'll adjourn to the lab. This is the specimen from the utility pole under GR60 coating law. It was coated with creosote, tar, and insecticides or aromatic hydrocarbons inside of it, PCBs, whatever you like to call them. And then the top is treated with our armor green primer for paint or coatings. We could coat anything with this. This is a fireproof coating. It's been infused into the wood. The line represents the difference from armor green and then the creosote. So this is our first specimen. We're going to test it with MAP gas, methylated acetylene, stabilizing propadiene, for 1 minute, and we're going to find out which one will hold up under this extreme heat. Now, the pole that we showed did not have armor green coating as a primer under it. This has a primer separate, and then we put a coating on a secondary specimen, and it's just a coating without primer also. But if you coat it with our primer, and then you attach your coating of 2 flame out in your coating, then you have a highly resistant, highly non-combustible, biodegradable, non-toxic, recyclable, environmentally safe material that kills bugs. Highly unscarifiable. Animals can't claw at it and sharpen their claws on it and hurt it. Woodpeckers can't peck through it. Sand can't blast through it. It coats the pole more or less kind of like a barrier, very similar to rhino bedliner, but it's not. It's our coating, very reasonably priced, compound 2 flame out, which is our product, and Aarmourtherm, which is our product here at Aarmourtherm. So we're going to try it out now. We're going to do the 1-minute ASTM E285 open torch test at 5,301 degrees with MAP gas, not MAP Pro. So are we ready?
Ready?
Let's bring it up to proper time on both levels, and we'll get a time set on it. Five, 4, 3, 2, 1. Oh. Let's restart that.
What, 15?
Start 15. 5, 4, 3, 2. Okay, we have off-gassing here. We want to find out what kind of PCBs or aromatic hydrocarbons and what rating of VOCs were released. What kind? What is our meter reading?
120.
This is a gas meter called a M40, and it registers some of the gases that are released. So on the camera, it'll show it. Now, we had minimal ablation, we had no combustion, we had no embering, we had minimal heat transfer, and we had some off-gassing of the materials, but it seems as though these materials were sequestered, because in here, what does it smell like to you? Like wood?
Yeah, well, it smells like a nice campfire.
Yeah, but it doesn't smell like a bunch of chemicals released.
Correct.
Because it seems as though our 2F, according to our meter, sequestered the VOCs in it. So now the camera will tell, because the hydrogen cyanide and the sulfates and the CO2 and the O2 and stuff released in the CO2 will be registered in that M40. Right, now we're going to do another test. We're going to turn this thing over, and we're going to continue the test based on a standard coating that they put on it from this line up. So we're going to turn this specimen over. So we'll stop for a minute and turn it over. This is a prototypical 8 inches away, and this is the creosote side of the specimen. We treated one side, so now we're going to see how the coating affected it with no combustion and very little smoldering, very minimal off-gassing. But now we're going to try it with the creosote-laden, aromatic hydrocarbon, which they put in it to kill bugs under the GR60 law, the dioxins in it. So we're going to run a 1-minute test here, and we're going to find out what happens with this side of the pole that's untreated without our Aarmourtherm coating. All right. Let's wait till 30.
Okay. 5, 4, 3, 2, 1.
There you go. 1 minute. Fully engaged. We have lots of off-gassing. We have volatile organic compounds in the form of released VOCs. We have full combustion. We have aromatic hydrocarbons. We have oblation. We have damage. A lot of smell. Different smell now, isn't it?
Nasty.
Smell. What does it smell like?
Petroleum.
Smells like
Nasty.
nasty kerosene, toxic smell. So we're going to adjourn for a minute. This is our ASTM 8-inch setback for the standard E235 open torch test for flame spread, combustion, heat transfer on this specimen that we took from this utility pole. Now, what we're looking here for is ablation. We're looking for sublimation. We're looking for carbonization. We're looking for off-gassing. We're looking for percolation. We're looking for cracking, crazing, and boiling and burning and embers. Whatever happens during this minute test. The STM requires a 30-second test from 8 inches away with propane, but we're using MAP gas, which is methylated acetylene stabilizer propadiene. This is not MAPRO. This is lab grade methylated acetylene stabilizer propadiene. It is 5,300 degrees. This is a very, very hot test, very high heat. So what we're going to do is for 1 minute on this jack pine or this Doug fir or whatever it is that the utility people put coating, this combustible coating on it. This coating seems to be as flammable as gasoline on a stick. This creosote, coated creosote, meaning that it's a kerosene additive dispersed in a tar residue mixture, coating over it according to the GR60 laws. And the coating underneath it, which is an oil to kill insects, is a coating called PCBs, or polybrominated diphenols, ethers. So when you see them, they're extremely toxic. So we'll do this test for only 1 minute. And what we'll do is we'll look for combustion and embering and off-gassing. So under the GR laws and under the ASTM laws and the E285 open torch test, this is a legal specimen test for a duration of 1 minute. You ready?
We start ready.
45.
5, 4, 3, 2, 1.
There you go. A little off-gassing. We have no combustion, no embering, extremely hot. That was a hot test. So apparently we heated up the coating so that the creosote, which is the tar and the kerosene inside of the pole, got so hot that it began to sublimate a gas. Very little gas, hardly any vapors, unlike the previous test. Now this piece of jack pine or Doug fir or northern pine that they use for utility poles is a standard tree under the GR 60 ruling. Now it's supposed to be impregnated with this oil and then coated with tar and kerosene, which is a standard pole. Now you can see that if this coating, which is high unscarifiable, it is highly inflammable, it's highly non-toxic, it does sequester VOCs, it lowers them, it stops combustion, it is self-extinguishing. So our Aarmourtherm 2 flame out is a very good product. So if you put it on a pole, or if you put it on your fence or whatever, and the animals come and they sharpen their claws on it, since it's highly unscarifiable, they can't sharpen their claws and cut holes in this paint. That would be highly impossible. It is much like rhino bedliner coating, but it's very, very environmentally safe. It's biodegradable, non-toxic, recyclable. So the pole would be recyclable, provided it didn't have, in these poles, didn't have all these PCBs and all of these creosote and tar. But the pole's longevity would be extremely long. It would be a high IR UV. It would be a coating that couldn't be destroyed unless you ran up and did it on purpose. So this is a very good coating for utility poles, fences, houses, construction, lumber, anything with wood, anything with even metal. So it's good coating.